Hello and welcome back for the notes for chapter 3.1. We are going to get into some graphing of equations, linear equations. And chapter 3, we're going to dive more into the parts and pieces of linear equations. So the first thing we have to know is how to graph and how the graphing system is all set up. This is called a rectangular coordinate system. It has 4 quadrants. Quad means 4. So this is 1, and it actually goes counterclockwise. So this is 2, down here is 3, and down here is 4. This is pointing to the origin where you always start. Just like if you were giving directions to someone, you have to have a starting spot. So the origin is always labeled 0, 0. Where X is always given first and Y is given second. Notice that X is your left and right movement on just like a number line, and then Y is your up and down movement, like a vertical number line. So let's do some graphing just so we can get a feel for this. So for example 1, graph the ordered pairs and label. So 3, 4, this is our X, this is our Y. So 3, 4, this is going to be our origin right here where they intersect. Letter A is going to be to the right 3 and up 4 because they're both positive. So 1, 2, 3, and then from there we're going to go up 4. 1, 2, 3, 4. That's A. Now B says we're going to go to the right 4, but we're going to go to the right 3, but we're going to go down 4. So to the right 3 and then down 4. 1, 2, 3, 4. There's B. C says to the left 1 and then up 3. To the left 1 and then 1, 2, 3. D is at the origin, our 0, 0 point. And then E is at -2, -5. So we're at a -2 and -5. A left 2, 1, 2, and then down 5. 1, 2, 3, 4, 5. Okay. Next up, we're going to learn about graphing. Now, for the most part, we're going to use Desmos for our graphing this semester, but it's good to understand how to do this by hand so that you can make sense and read the Desmos graph. Sometimes it's also helpful to make an XY table before graphing. XY means we're going to put a value in for X, and then we're going to find out what Y is so that we can create coordinate points to graph. I always like to put convenient ones. So 0 in for X. If I put 0 in for X, I will have a -1/4 times 0, which equals 0. So my coordinate point is 0, 0. Okay. If I put a -1 in for X, again, I'm just putting in some convenient ones. I will have a -1/4 times the -1, which gives me a +1/4. So my coordinate is a -1, +1/4. So I'm going over to the left 1 and then up 1/4, so barely up. There is a point. I'm going to put in +1. So I have a -1/4 times a +1. So this gives me a -1/4. So my coordinates are 1 and a -1/4. So up to the right 1 and then down a -1/4. So it's starting to look like this. And then once you get 3 or 4 points, I'm also going to put in 4 because 4 will cancel out this fraction. So that might make it easier. So I'm going to put in a +4. So a -1/4 times a +4 gives me a -1. So I have the point 4, -1. 1, 2, 3, 4, and down 1. So I'm going to just take a flat piece of paper, straight edge of some sort, and draw this. Oops. It's not drawing through my points very well. There it is. Okay. Now, example 3 says, graph the line y equals a negative 1/4 x plus 2. So if you can see, we really have the first equation, and then we're just adding 2 to all of our outputs. Okay, so if we make an XY table here, I'm going to put in the same x's and see what we get for y's. So when I put in 0 for x, I'm going to have a negative 1/4 times 0 plus 2. That comes out to be 2. So I have the point 0, 2. I'm going to plot these in a different color here in a moment. And then if I have a negative 1, I'm going to have a negative 1/4 times a negative 1 plus 2. So this is going to be a positive 1/4 plus 2 is 2 1/4. So we'll be at a negative 1, comma 2 1/4. And then a positive 1 will be a negative 1/4 plus 2. So it's only 1 3/4. And then a positive 4 plus 2 gives me a negative 1 plus 2 is a positive 1. So we'll be at the point 4, comma 1. So let's graph these in a different color here. So we're at 0, 2. And then a negative 1 and 2 1/4. And then a positive 1 and 1 3/4. And then a positive 4 and 1. So 1, 2, 3, 4, and 1. So this is called a translation, which we're actually going to talk about in part D. Notice that this appears to be the same line. It's just all shifted up 2. So we did the X thing, right, where we X influenced our value, and then after that we added 2. So let's kind of think about that. Okay, next up, we're going to do some graphing, but we're going to just look at lines that are through the origin. So any line that has the equation y equals mx, we're not adding or subtracting anything afterward, always goes through the origin. So you can see here, let's make an XY table for this one. And at the same time, we can make one for this one, and we can graph them both. So I'm going to challenge you to go to Desmos, and let's make this table in Desmos. Okay, so in Desmos, I am going to do y equals 2x. And it draws the line, which is good because we are going to draw the line. You can see it goes through the origin there when I hover over that point. And then I'm also going to do y equals a negative 3x. And that one also goes through the origin. And if we want to make an XY table, we can go up to this gear. Do you see where my mouse is? And it says edit list. Click on that gear, and then we can click on the table. And then if we go down and highlight the other equation and go up to the gear, we can also click on a table. So both of them we can make tables for. So if we put in the value a -2, the first equation is a -4, and the second equation is a 6. So I'm just encouraging you to go and write down these values in your table on your paper. And then we will go back and check on them together. And it would also be good for you to save this in Desmos as Math 104 Lesson 3-1. Back to our paper here. I just made my table. So I put these X's in for both, and these are my outputs for the 2x equation, and this is the one for the -3x equation. So for the 2x equation, I'm at a -2 and a -4. Here's one of them. A -1 and -2, and it goes through 0, 0, and then +1 and +2 and +2 and +4. There is that line. Okay. And that is that line right there. Notice that it's moving in a positive direction when we read left to right. Just like we read a book, we read left to right, and this equation left to right goes up. You can follow that with your pen. Also notice that the 2 is positive. There's going to be a link to that later on in the lesson, in the chapter. Okay, let's plot the other one. So we have a -2 is x and a +6. We're going to plot the other equation, a -3x. So a -2 and a +6. 1, 2, 3, 4, 5, 6. Okay, I'm going to do that with my pink. And then a -1 and +3. -1 and +3. They share the point 0, 0. And then a +1 and a -3. And then a +2 and a -6. Then I'm going to connect those dots here. And that's this line here. And then we can make a connection if we move from left and right. The pink equation is going downhill from left to right. And it's going downhill, so its slope is negative, right? If you're thinking about going downhill. And we can make a connection that the 3 is a -3. That's also negative. And the picture is negative going downhill. So we can make that connection. Okay. Part D is all about those transformations that I mentioned. So back on B, when we did our graph here, I had you graph a -1/4 x, and then I had you graph a -1/4 x plus 2. And so the plus 2 happened after we did the influence of x on the -1/4, right? So it was afterwards. So we did the -1/4 x, and then we added 2. So everything was just shifted up 2. That is this translation here of k units up because we added 2. Now, if we would have subtracted 2, everything would have been shifted down. So this is applying it to a linear equations because they're of the form y equals mx plus k or plus b. These, this is shifting of these units up and down as well. This is to what's called a quadratic equation. And we're going to focus on this in later chapters, but we can still look at the graph of this equation. So let's look at example 5 here. I want to just focus on the linear and the translations for the linear. So let's look at the base equation. The base equation is just what's happening to x. So the base equation here would just be y equals 2x. Y equals 2x is going to have the point 0, 0. We just looked at that over here, right? The 2x is going to have the point 0, 0, the point a negative 1, 2, a negative 1, a negative 2, and a positive 1, and a positive 2. So it's going to look like this. And then we have the translation of a positive 3 means that everything is going to be shifted up 3. So if we look at this on the xy, we'll look at the base equation of a negative 2, a negative 1, 0, 1, and 2. Let's fill in what we know from the previous. We know it's a negative 4, a negative 2, 0, 2, and 4. And then we have a translation of a positive 3. That means everything's going to be shifted up 3. So when we shift up 3, we're just adding 3 to our outputs. So a negative 4 plus 3 means that that will now be a negative 1. So this will be at the point in negative 2 and negative 1. And then we're going to add 3 here. Will be a positive 1. So we'll be at the point in negative 1, 1. I'm going to draw that in a red. So this will now be a negative 2 and 1. I'm sorry, negative 2 and negative 1. Sorry about that. Negative 2, negative 1. And a negative 1 and 1. And then the 0 will be 0 plus 3. So that will be at 0, 3. And then we add 3 to 2, and we'll be at 1, 5, and then 2, 7. So 0 and 3, and then 1 and 5. And then 2 and 7. So it's the same line, it's just shifted up 3. Everything is 1, 2, 3 up, 1, 2, 3 up, 1, 2, 3 up. Okay. Now, let's look at this one. We're going to look at this one in Desmos. The base equation on this one is, again, just the piece that has x on it. So the base equation is just a negative 1/3 x. Let's go to Desmos and look at these. I'm going to turn off my graphs by clicking on the circles and the dots, so everything kind of goes away. I'm going to go down here and click on a new line and type y equals a negative 1 divided by 3, makes a fraction, then arrow right to put the x on it. So there's our graph. And then I'm going to copy that. Control C lets you copy, and Control V, as in Victor, will let you paste. And then I can just say subtract 4. So you can see I'm going to actually make them a different color too. By clicking on that line, I can go up to my gear and I can click on and change the colors. I'm going to change that to purple so I can see the difference between them better. So you can see the green line was our original equation and the purple line is our shifted down 4. Again, keep saving this so that you've got some good reference in your Desmos. The next topic we're going to look at in this lesson is, let's go back to my paper here, are intercepts. When we think of the word intercept, we think of something breaking through, maybe like a barrier. So it says an x-intercept of the graph of an equation is the x-coordinate of a point where the graph crosses the x-axis. Okay, so let's just write this down. X-intercept is an x value when y is 0. It's the x where we're crossing the x. And the y-intercept is the y value when we're crossing at x equal to 0, where we're crossing the y-axis. Okay. So if we were to draw a graph here, let me draw a line. This is my line here. And this point right here is crossing the y-axis. This is my y-intercept. When x is 0, it's my y-intercept. And this one here is crossing the x-axis. This is the x value when y is 0. It's my x-intercept. So example 6 says find the intercepts for the following. So we have this equation here, and we're going to find the x-intercept. So the x value when y is 0. So I am just going to replace y with 0 and solve for x. This one is harder because you actually have to move things to the other side to solve for x. The y-intercept is usually easier to find. So in this case, we're going to add 2 to both sides. We've been doing this for a couple weeks now, so we should be getting pretty good at solving some basic equations. So we have 2 equals 4x. And then to solve for x, remember, we're only worried about the things attached to x. So we have to divide by 4. And we find out that x is 2/4 or really 1/2. So my x-intercept is equal to 1/2, 0. Let's highlight that if you have a highlighter. That's an important thing we just found. Now we're going to find the y-intercept. So the y-intercept is actually easier to find. It is when x is 0, we're finding the y value. So we're going to let x equals 0. So y equals 4 times 0 minus 2. That's going to be y equals a -2 because that goes to 0. So my y-intercept is 0, -2. Much easier to find because when we let x equal to 0, that's all on the right-hand side. So it's easier to just simplify. Let's highlight that. That's important as well. So having these descriptions marked for yourself is important. Maybe getting some you can go to the dollar store and get a package of a bazillion of these little skinny ones, and you could just label on there intercepts. And then you pull it off, and you're just going to mark it on a tab of your paper right here. And then you can find it really quick when you go to work on those pages. Just an idea. Okay, let's find intercepts for this one. So the x-intercept is the x value when y equals 0. So 0 equals a -1/2 x plus 1. And we learned that if we multiply through by 2, we can get rid of our fractions. So I'm going to multiply this by 2, multiply this by 2, and multiply this by 2. So I get 0 times 2 is 0 still. That's nice. Now my 2's cancel on my fraction, so I'm left with a -1 times x. So a -1x plus 1 times 2 is 2. Excuse me. I'm still trying to solve for x. So I'm going to subtract 2 from both sides. I'm going to divide by a -1. So we get x equals a +2. So my x-intercept is at 2, 0. Again, important enough to highlight. And then my y-intercept is when x is 0. So y equals a -1/2 times 0 plus 1. That goes to 0, so y equals 1. So my y-intercept is at 0, 1. You'll notice, you may have already noticed, that when our equations are in this form, y equals m something, your slope, times x plus or minus something, the plus or minus something is your y-intercept. See, it was 0 and 1 for this equation, and up here it was 0 and a -2. So that's an important key. We're going to look at more at slope in the next lesson, 3.2. So we're going to finish up lesson 3.1 right here with some drawings of basic lines that are horizontal and vertical. So they have special equations and they're nice and simple, which is great. So a line that is through the origin, we've already looked at. It's ones like here on the left. They go through the origin 0, 0. I'm trying to get the zoom. It's still kind of blurry here. Okay, so this line with the origin is y equals mx. Remember, there's nothing being added or subtracted. So, similar to this one here in part A, explain if the graph is vertical or horizontal or if it's through the origin. So this is through the origin. Now, the other two special cases, one is a vertical line. So a perfect vertical line is going to be an x equal to just a number, an x equal to a number. So that would be this one down here, letter C, is going to be a vertical line. And then the third situation can be a perfectly horizontal line. And that's just going to be y equal to some number. So that would be letter B, is a horizontal line. So lots to think about in this lesson. Catch me back for lesson 3.2.